How does a machine actually understand a sentence? I don't mean just recognizing the words, but seeing the hidden connections between them. Well, there's a specific technique for this, and it's called dependency parsing.
All right, let's start with a classic puzzle. Listen closely to this sentence. I shot an elephant in my pajamas. So, who's wearing the pajamas?
To us, the answer is probably obvious. But for a machine, it's genuinely ambiguous. Is it me in the pajamas or the elephant? Without understanding the sentence's structure, both are possible. By the end of this short explainer, you'll understand exactly how machines create a grammatical blueprint to figure this kind of thing out.
Okay, so let's talk about that blueprint. What is it, really? Think of it like a map for the sentence. It's not about the order of the words on the page, but about how each word is grammatically tied to another.
And that process has a name: dependency parsing. It's all about finding these dependency relationships. The key thing to get is that we're looking at which words depend on other words. You know, which word modifies another, which word is the subject of a verb. It's all about these direct one-to-one connections.
The best way to understand this is to just build one. Let's take that classic sentence. The quick brown fox jumps over the lazy dog.
The whole process is actually pretty logical. First, you find the main action, the absolute core of the sentence. We call this the root. Here it's jumps. Simple enough. Now, who or what jumps? The fox. So we draw a line, a dependency, from jumps to fox. Okay, what about the words describing the fox? The, quick, and brown all modify fox, right? So they all connect directly to fox. And finally, where does it jump? Over the dog. This whole phrase tells us more about the jump, so it connects back to our root, jumps. And just like that, we have a clear, structural map. We can see exactly what's connected to what.
Okay, so we've got the general idea down. Now let's put some official names to these concepts so we can talk about them like engineers. We just need to know about heads, dependents, and labels.
So in every one of these connections, one word is the boss and the other one works for it. The boss is the head. The word that modifies it or depends on it is the dependent. Take brown fox. The main word is fox, so that's the head. Brown just describes the fox, so it's the dependent. See? One governs, one depends. Simple.
Now, you might have heard of another way to do this called constituency parsing. That's the one that groups words into big chunks like noun phrase or verb phrase. Dependency parsing is different. It's more granular. It cares about the direct link between John and C's and Bill and C's. For a lot of practical AI tasks, knowing these direct word-to-word relationships is just way more useful than knowing you have a big abstract phrase.
And these connections we're drawing aren't just lines. Each one gets a label that tells you the type of grammatical relationship. You'll see things like N-subject, that's short for nominal subject, or DOB for direct object. The cool thing is, there's a standardized set of these labels, thanks to projects like universal dependencies. That means we can build these blueprints consistently, even across different languages.
Okay, this is all very cool, but where does it actually show up in the real world? How is this blueprint used in AI systems we interact with every day?
Well, it turns out dependency parsing is working behind the scenes in a ton of places. When a chatbot needs to figure out what you actually want to do, that's parsing. When a sentiment analysis tool needs to know what you're happy or angry about in a review, that's parsing. It's also key for extracting structured information from text or helping a search engine understand a complex query.
Let's make this super concrete. Imagine you type this into a support chatbot. I need to update my billing address. Now, a basic keyword search might just see billing and address and get confused, but a system using dependency parsing immediately sees the structure. It knows that the main action, the root, is update. And what is being updated? The object, address. That direct link is everything. It tells the bot exactly what you're trying to do, so it can give you the right response.
So if you remember one thing, let it be this. Dependency parsing is how machines see a sentence's structure by mapping out the relationships between its words.
And that leads to the big takeaway here. To truly get to the meaning of what we say, a machine first has to understand the structure. Structure comes first.